Namaste and welcome back to JEE Chemistry with Typical Monk. This is class 12. Redox reactions. Rust on iron, the current from a battery, respiration in your cells, the budding of a feud. Every one of these is the very same thing underneath, a trade of electrons. One species loses electrons, another gains them, and we keep track of the whole deal with a single bookkeeping number, the oxidation number. Today, we learn to read that number, to balance any redox equation cleanly, and to turn a titration into one single line using the equivalent concept, which JEE loves, one idea at a time. Here is what you will learn today. First, oxidation and reduction as electron transfer, the mnemonic oil rig. Second, the oxidation number rules, and reading the oxidation number ladder. Third, balancing a redox equation by the ion-electron or half reaction method. Fourth, the N factor, the equivalent mass, and redox titrations. And fifth, disproportionation and a set of JEE drills, match, and numericals. One idea at a time. The whole chapter fits into one mnemonic, oil rig. Let us open it out. Oxidation is loss. OIL, oxidation is loss of electrons, and when a species loses electrons, its oxidation number rises. Production is gain. RIG, production is gain of electrons, and when a species gains electrons, its oxidation number falls. The word reduction and the number both go down together. Then, the two agents. The oxidizing agent is the one that is itself reduced. It takes the electrons. The reducing agent is the one that is itself oxidized. It gives them away. And the oxidation number itself, a signed count of the electrons a species has gained or lost. It is the ledger in which every redox trade is recorded. Now watch a real reaction. Zinc dropped into a copper ion solution. Zinc plus the copper ion gives the zinc ion plus copper. Look at the two half trades. The oxidation half, zinc loses 2 electrons, and its oxidation number rises from 0 to +2. Zinc is oxidized. The reduction half, the copper ion, gains exactly those 2 electrons, and its oxidation number falls from +2 down to 0. Copper is reduced. So the agents, zinc is the reducing agent because it gives the electrons away, and the copper ion is the oxidizing agent because it takes them. The electrons flow from the reducing agent to the oxidizing agent. And conservation ties it together. The electrons lost must exactly equal the electrons gained. That is why the two half reactions always balance, and why we balance them by electrons. Now, how do we actually assign an oxidation number? A short set of rules, applied in order. A free element is 0. Zinc metal, oxygen gas, all 0. And a monatomic ion equals its charge. The sodium ion is +1. The chloride ion is -1. Oxygen is -2, almost always. The exceptions to remember are -1 in peroxides, like hydrogen peroxide, and +2 in oxygen difluoride. Hydrogen is +1, almost always. The exception is -1 in the metal hydrides, like sodium hydride and calcium hydride. And the sum rule closes it. All the oxidation numbers add up to 0 for a neutral molecule, or to the ion's charge for an ion. Set that sum and solve for the one unknown. Now, the JEE favorite numerical, the N factor and the equivalent mass for potassium permanganate in acidic medium. Its molar mass is 158. The oxidation number change first. In acid, the manganese in permanganate goes from +7 down to +2, a gain of 5 electrons. The N factor. The N factor is simply the number of electrons exchanged per formula unit. So here, N equals 5. The equivalent mass. Equivalent mass is the molar mass divided by the N factor, 158/5, which is 31.6 grams per equivalent. The titration. At the end point, the equivalence N1V(1) equals N2V2. The equivalence of oxidant equal the equivalence of reductant. So the answer. The N factor is 5. The equivalent mass 31.6. And note, in neutral medium, where it goes to manganese dioxide, N is 3. In strong base, where it goes to the manganate ion, N is 1. The medium sets the N factor. Now, beautiful way to see one element's whole redox life. The oxidation number ladder. Here it is for manganese. The ladder, one element, its species stacked by their oxidation number, from manganese metal at 0 up to the +2 ion, +4 in manganese dioxide, +6 in manganate to +7 in permanganate. Going up the ladder is oxidation. The oxidation number increases and electrons are lost. Going down the ladder is reduction. The oxidation number decreases and electrons are gained. And a special case, disproportionation, where one element sitting in a middle state moves both up and down at once. Chlorine gas, at 0, splits into the chloride ion and the hypochlorite ion, reduced and oxidized in the very same reaction. Now what JEE actually asks. 5 pointers. 1. Oil rig. Oxidation is loss. Reduction is gain of electrons. The oxidation number rises in oxidation and falls in reduction. 2. The oxidizing agent is reduced and the reducing agent is oxidized. Never mix these two up. It is the most common slip in the chapter. 3. The ion-electron method. Balance the atoms, then balance oxygen with water, hydrogen with the hydrogen ion in acid, and finally the charge with electrons, then add the two halves. 4. The N factor is the electrons exchanged per formula unit, and the equivalent mass is the molar mass divided by the N factor. And 5. At a titration endpoint, N1V1 equals N2V2 equal equivalence. That is JEE's favorite one-line redox shortcut. Now an assertion and reason drill. For each pair, are both true, and does the reason explain the assertion? First pair. Assertion, in the reaction zinc plus the copper ion, zinc is the reducing agent. Reason, zinc loses electrons and is itself oxidized. Both are true, and the reason directly explains the assertion. The answer is A. Second pair. Assertion, the oxidation number of oxygen is -2 in every one of its compounds. Reason, oxygen is a highly electronegative element. The reason is true, but the assertion is false. Oxygen is -1 in peroxides and +2 in oxygen difluoride. So the answer is D. Third pair. Assertion, in a disproportionation, one element is simultaneously oxidized and reduced. Reason, a disproportionation is a type of redox reaction. Both are true, but merely being a redox reaction does not explain the same element point. So the reason does not explain the assertion. The answer is B. Now match each species to the oxidation number of the marked element. Manganese in the permanganate ion goes to +7. Chromium in the dichromate ion goes to +6. Sulfur in the sulfate ion goes to +6. And nitrogen in ammonia goes to -3. 4 species, 4 numbers. Work each one from the sum rule. Now, how many of these 3 statements are correct? 1. In oxidation, the oxidation number of the species increases. That is correct. Oxidation is loss of electrons. 2. The oxidizing agent is itself oxidized in a redox reaction. That is wrong. The oxidizing agent is itself reduced. 3. The N factor of potassium permanganate in acidic medium is 5. That is correct. +7 down to +2. So the answer, 2 are correct. Statements 1 and 3. The trap is statement 2. The oxidizing agent is reduced, not oxidized. Now the 2 mistakes that quietly cost marks. The myth, the oxidizing agent is the species that gets oxidized. The truth, the oxidizing agent gets reduced. It oxidizes the other one. It is the reducing agent that gets oxidized. Read the 2 words as opposites. The second myth, the equivalent mass of a substance is a fixed constant. The truth, it depends on the reaction. Equivalent mass is the molar mass divided by the N factor, and the N factor itself changes with the medium. Permanganate is 5 in acid, 3 in neutral, 1 in strong base. Now test yourself, answer before the reveal, and work the number in your head. That is how G speed is built. Here we go. Question 1. The oxidation number of sulfur in sulfuric acid? +6. Question 2. The oxidation number of manganese in the permanganate ion? +7. Question 3. The N factor of potassium permanganate in acidic medium? 5. Question 4. In zinc plus the copper ion, which one is oxidized? Zinc. Kenpu ashma. Ashma. And question 5. The equivalent mass of potassium permanganate in acid with a molar mass of 158 over 5, 31.6. Let us gather it all in one breath. Oil reg, oxidation is loss of electrons, so the oxidation number goes up. Reduction is gain, so the number goes down. The oxidizing agent is reduced. The reducing agent is oxidized, and the electrons flow from the reducer to the oxidizer. The oxidation number rules: a free element is 0. Oxygen is usually -2, hydrogen usually +1, and the sum equals the net charge. Balanced by the ion-electron method, and the N factor is the electrons exchanged per formula unit. The equivalent mass is the molar mass divided by the N factor, and at a titration endpoint, N1V1 equals N2V2. Next class, solutions, the concentration terms, Hall's law, and the colligative properties. From rust to batteries, every redox reaction is one single electron trade. And you can now read the oxidation number, balance the equation, and settle a whole titration in one line with equivalence. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time, you will crack G. I will see you in the next class.